Hey guys, welcome to part 2 of 4.4 FTC. So let's go to move on with the next example. In the next example, we have a function, an absolute value function that we're integrating from 0 to 3. So let's go ahead and pay attention to the inside of this function. What kind of function is that? That is the line 2x minus 1. And we're taking the absolute value of that function. Now, what does it mean to take the absolute value? To take the absolute value of a function pretty much means that, well, what does it mean to take the absolute value of anything? For example, what if I say the absolute value of 5? You'll tell me it's 5. What about the absolute value of negative 5? It's still a positive 5. So the absolute value of anything will turn anything that's negative into a positive. In other words, we just want to know its magnitude. But when we're taking the absolute value of a graph, it's a little bit different in terms of like how you should draw things. So we know that y equals 2x minus 1 has a y-intercept at negative 1, and then we have a slope of 2, so it's rise of 2, run of 1. And then I'm going to go ahead and connect these 2 points like that. So this is the line y is equal to 2x minus 1. Now when we take the absolute value of a function, whatever is negative in the function will become positive. Well, what does it mean for a function to be negative? A function is negative if it lies below the x-axis, like this. Okay, so how do we take the absolute value of a function? Whatever is negative becomes positive. So we flip it. We flip this negative part about the x-axis like this. Okay, it may not be an exact flip, but there it is. You know what? I should probably just draw this a little bit better. Maybe like that. Okay, so the absolute value of 2x minus 1 is this v. Notice that this v does not cross the x-axis, does not even go to the negative side. It just stays at 0 or greater than 0. Okay, so this red arrow, disregard from now on. We already took care of this negative part of this function. So how do we integrate an absolute value function? Well, we want to integrate from 0 to 3, which means we want to find the area under the curve from 0 to 3, but we have a little small problem here. That is not 0. This is 0. So I have a little area here. Hopefully you can see this little shaded region that I'm doing here. I have a little area there that I need to compute. Except I don't know what that little x-intercept is. I don't know. How do you find the x-intercept of a linear function? You simply set the function equal to 0 and you solve. So that x-intercept is actually 1/2. Now, you can't take the integral from 0 to 3 because if you take the integral from 0 to 3 of the regular function without the absolute value, you're going to get negative area. If you can see this negative shaded region, you're going to get negative area plus a positive area, and that'll skew your area. It'll be an incorrect answer. So what you want to do is you want to take the area of this absolute value function from 0 to 1/2. But if you notice, this function, or that flipped part of the negative part of the function, is not the same thing as 2x minus 1. What is it? We flipped it. So that means when you flip something across the x-axis, you negate the function, and really that function is really negative 2x plus 1 dx. That is this part right here. And then of course we integrate from 1/2 to 3 to get this area here, not including whatever is before 1/2. And we don't have to worry about flipping any function because that is the original linear function that we were dealing with already. So whenever you're dealing with absolute values, you're going to be dealing with at least two integrals in the same problem. One's going to be flipped, the other one's going to be original, vice versa. If you're dealing with more than if you're dealing with more than two integrals, then you're probably going to have two regular functions, one flipped, or vice versa. So let's go ahead and integrate this first function here. The integral of negative 2x is negative x squared plus x from 0 to a half plus the integral of 2x minus 1 is x squared minus 1x from 1 half to 3. Now we can go ahead and plug in our upper and lower bounds. Negative 1 half squared plus 1 half minus negative 0 squared plus 0, which you'll know that this all becomes 0. And then it's plus now the second part. 3 squared minus 3 minus a half squared minus a 1 half. And then let's go ahead and compute this. What's a half squared is 1/4 negative plus a half plus 3 squared is 9, take away 3, and then distribute, which is going to be a negative 1/4 again and a positive 1 half. So let's go ahead and combine all the like terms. But what I mean by like terms, combine all the whole numbers and then combine all the 1/4 and then finally combine the halves. Okay, 9 minus 3 is 6. Negative 1/4 minus a 1/4 is a negative 2/4. A 1 half plus a 1 half is a whole, and now you have 7 take away a 1 half, which is put it over 1, 14 over 2, take away a 1 half, which is 13 halves, is your answer for this problem. So absolute value integrals, you're going to have to be dealing with at least two integrals. They're not going to ask you an absolute value, an integral of an absolute value in the AP exam if it doesn't deal with at least two integrals. So next problem, same thing. This time we have a square root. This time we have a quadratic. Let's go ahead and draw this quadratic, x squared minus 4. We know that x squared is a U-shaped graph. Minus 4 means translates down to 4 units. Something like this. It's not going to be perfect. And we want to integrate from negative 1 to 3. Well, first of all, let's figure out what these x-intercepts are. Again, how do we find the x-intercepts of functions? We set the function equal to 0, and we clearly see that it's plus and minus 2. So this is a negative 2, this is a positive 2. We're integrating from negative 1 to 3. So how would that look like? We're integrating this. Oh, well, before I continue, okay, I totally forgot that this is an absolute value function. What does it mean to be absolute value? Whatever's negative becomes a positive. So in black, this is my new function. 1, 2, 3, 4. It's not going to be perfect. Here it comes. The black function is now my function here, the absolute value. So I'm really trying to integrate from negative 1 to 2, and then from 2 to 3. And wherever that area ends up there. Okay, so I need to split this up into two integrals. So it's going to be from negative 1 to 2 and from 2 to 3 of the functions, well, this black function here is not the original function, it's the flipped function. So I had to flip x squared minus 4 by negating it. So it becomes negative x squared plus 4. That is my flipped parabola. And then from 2 to 3 is my original parabola. So no need to flip this. It's just x squared minus 4, which is the original. And let's go ahead and integrate. Negative x cubed over 3 plus 4x. And then from negative 1 to 2 plus x cubed over 3 minus 4x from 2 to 3. And then we can go ahead and apply the FTC, apply the upper minus the lower. So let's do the upper first. So if I plug in 2, I get negative 8 over 3 plus 8 minus, now I got to be very careful, I have a negative. A negative 1 cube is a negative 1, but there's already a negative in front of my fraction, plus a 4 times negative 1 is a negative 4. So this should be a minus 4. Now we do the second FTC of this part. So 3 cubed is 27 over 3. And then it's 4 times 3, which is 12, minus 2 cubed over 3, which is 8 over 3, minus 2 times 4 is 8. Okay, now let's go ahead and continue. Let's go ahead and let's not deal with this part here. Let's just rewrite this as negative 8 thirds plus 8. And then here you have a triple minus. Look at this, triple minus. A triple minus is still a minus. A negative times a negative is a positive. 27 over 3 is really just a 9 minus 12. Distribute negative 8 thirds. That is positive 8. And then all we have to do is combine fractions and whole numbers. 8 plus 9 plus 4. And then plus 8. And then minus 12. So let's go ahead and do that first. 8 plus 4 is 12, plus 9 is 21, plus 8 is 29. Take away 12, and that is 17. And then let's go ahead and do the fractions. If I'm going too fast, you guys can just pause the video and repeat. A negative 8 thirds take away a 1 third is 9 thirds. Take away 8 thirds more is 17 thirds. So now I have 51 over 3, take away 17 thirds, and that is, I think it's 34 over 3. And that would be your answer. Last problem, we're almost done. Find the area bounded by the graph of 2x squared minus 3x plus 2, the x-axis and the vertical lines x equals 0 and x equals 2. So they're telling you to find the area, but they're not giving you an integral problem like the problems before. They're not telling you, hey, take the integral of this and this. No, they're telling you what to find the area of and in between. So find the area bounded by the graph y equals x squared, y equals 2x squared minus 3x plus 2. So we know that that's a parabola that's facing up, and I already know it's a parabola with a y-intercept of 2. Okay, that's the first part. That's 1. It's also being bounded by the x-axis. So I'm going to go ahead and just draw a line here. And also the vertical lines 0 and 2. X equals 0 is a vertical line at 0. X equals 2 is a vertical line at 2. Now this may not be to scale. So what is bounding? Okay, what is the region being bounded by all these 4 things? The region being bounded is right here. All this area there. That is what we're trying to find. So if we look at it, if we look at this, we're really finding the area under the curve 2x squared minus 3x plus 2, of course with respect to x, from where to where? From 0 to 2. You might be asked to do problems like this in an AP exam. It's really an integral problem, but they don't tell you in integral form. All right, so let's go ahead and integrate. 2/3 x cubed minus 3/2 x squared plus 2x from 0 to 2. So it's 2/3 times 2 cubed minus 3/2 2 squared plus 2 times 2 minus 0. If you plug in 0 into all your x's, you get 0. So this really becomes an easy problem. So it's 2/3 times 8 minus 2/3 times 4 plus 4. This becomes 16/3. 2 into 4 is 2. 3 times 2 is 6 plus 4. This becomes 16/3. Take away a 2, which becomes 16/3. Take away a 6/3. Your final answer is 10/3. That is the area of this red shaded region.